All right, good day and welcome back to Everything Mathematics. And today, as I said yesterday, we're going to jump straight into applying various questions with surds. And tomorrow, God's willing, maybe I'll do a general video practicing so that I will just try maybe different questions and address or see how well we could apply the various rules before we go on to our next series. So tomorrow, God's willing, we're going to wrap up this whole thing with surds. Of course, unless you have a question, I'll gladly do it. But with no further ado, let's get started. So, supposing we're asked to simplify or not simplify, we will be asked to rationalize something like this. So I'll start with question 2 because yesterday we pretty much did question 1. So question 2, we have what? 6 over 3 minus root 3. And again, remember, we're rationalizing. So this is what was the essence of maybe rule 6, as I said yesterday. But because I don't want to kill both two birds with one stone, I did rule 6 and rule 5 as one. Because it's just a matter of changing the sign, right? So this we multiply now by, before I go into solving, this is a given question. So we were asked to rationalize this, rationalize. So all I'm going to do now is go straight off the bat by multiplying by the reciprocal. So I multiply this by, remember the reciprocal, we just change the sign. So we have 3 plus root 3, and we do the same thing at the bottom, at the top, 3 plus root 3. And we just simplify from here. Of course, if you cannot see it from here, you could do what I did yesterday. You just bring it a little closer so you could see how the expansion is taking place. But that's up to you. Based on your level, from here, you could jump straight to the answer, to be quite honest. But here now we have 6 times 3 and then 6 times root 3. So at the top here, we'll end up with the likes of 18 plus 6 root 3. Yes? So the 6 multiplied by this 3 gave me 18, and then the 6 multiplied by root 3 gave me 6 root 3. And that's how I end up with that. At the bottom, it will be a little trickier, but I trust you could follow. So at the bottom, we will have now 3 times 3, that will give me 9. Then I have to watch. In fact, when you really bust with this, you could see right away that you'll end up with 9 minus 3. In fact, that's the level you're supposed to be at. But of course, when you're required to see your answers, you have to go through the whole process. So of course, at the bottom here, we will end up with 6. We could see that right away. But that comes with continuous practice, of course. Then, so I do the 3, but regardless, you still have to show your working, so get used to it. So 3 times 3, that will give me 9. Then I'll do 3 times root 3, that will give me 3 root 3. Negative. No, not negative, sorry. Positive. Because I'm doing this 3 with this root 3, so it's positive. Now I'm going to the negative root 3. So negative root 3 times 3, that will give me negative 3 root 3. And then negative root 3 times a positive root 3, I will get a negative 3. Yep. And again, here is where you make your elimination. Positive, negative 3 root 3 will cancel positive root 3. Good. So that leaves me with that. And that will ultimately leave me with 18 plus 6 root 3 all over 9 minus 3. And 9 minus 3, we could see that will leave us with 6. Good. And we could simplify further. Remember from here, since we have one denominator, we could split the denominator. So that will be 18 over 6 plus 6 root 3 over 6. 6 could go into itself once, 6 could go into 18 3 times. So that will leave us with 3 plus root 3. Because 6 here would cancel this 6. Wow, this answer was pretty interesting. I didn't see this one coming. So this is our final answer here, 3 root 3. So when we rationalize 6 over 3 minus root 3, we will actually get a result of 3 plus root 3. Easy does it. Let's do another example. So that was example 1 for today. Let's do example 2. And of course, this is where it starts to get a little more interesting. Well, example 3, question 3, which is example 2 for today, because you know we started yesterday. Right. So we have 2 plus root 3. So notice here now at the top, we have an expression itself and not just a single number as we've been doing before. But the rule remains the same. and then we have 2 minus root 5. Good. So yes, this one might seem complicated, but it's the same thing. You just have 2 expressions to multiply. But what you're paying attention to is the bottom, because the bottom is what determines what we're rationalizing. So then here, we simply multiply by the reciprocal of the bottom. It's negative, so that means we multiply by positive root 5, and we do the same thing on top. So we have 2 plus root 5. So it's the denominator that determines what we're multiplying by, and not any and anything we feel like. So sometimes some persons might see this expression at the top and say, okay, let me just change the sign of the top and multiply top and bottom. No, you always pay attention to the bottom, the denominator. Why? Because remember, the whole process of rationalizing is ensuring that there is no square root at the bottom left as an answer. If we go back to the one we did earlier, notice root 3 no longer remain at the bottom, it came on top in essence. And we have root 6 there. I mean, just 6. And even our final answer, this one worked out so nice that we don't even end up with a denominator. We just end up with one numerator of 3 plus root 3, because that could be the same thing as that over 1, right? Here now, let's simplify now. So 2 times, let me just get some colors here. So I'm doing 2 times 2, and then 2 times root 5. Let me do that first, so it wouldn't get too cumbersome. So 2 times 2 at the top, that will give me 4. And 2 times root 5, that will give me 2 root 5. Good? So that's for the 2 there now. Now I'm doing the same thing, but with the root 3. Not with the root 3. So I have root 3 times 2 and root 3 times 5. And notice this is positive root 3. Always pay attention to your sign. It's very important. So positive root 2 times 2, that should give me positive 2 root 3. And positive root 3 times 5, that would actually give me root 15. And again, this is like the reverse of rule 1. Remember rule 1, if we have root 3 times root 5, that's the same thing as root 3 times 5, which is ultimately the same thing as root 15. So it's like almost as if we kind of reversing it, it's like we're going back pretty much. But yeah, that's basically what happened. So that's how we get root 15. Don't be too alarmed. It's not that complicated. Come on, it's not that complicated. Good, let's go. Now we're going at the denominator. We're going to see if we could simplify anything on top here. I'm not sure. I didn't work out anything yet. But from what I'm seeing there right now, it seems like that's the simplest one we could go. I ain't seeing nothing that could work out with each other. But anyway, we'll discuss that after. At the bottom now, we have 2 times 2, and then we have 2 times root 5. So the 2 times the 2, that will give us 4. And the 2 times root 5, that will give us positive 2 root 5. Good. And that gets rid of that arrow there. And let's try that again now, but with 3, with the minus 5. So now it's minus 5 times 2, minus root 5, sorry. And then minus root 5 times this here, right? So let's see what that gives us when we do that. Minus root 5 times 2, that will be minus 2 root 5. And minus root 5 times positive root 5, that will be minus 5. The negative will prevail in terms of sign, and the 5 will just square root each other to get 25, and then after we root it to get 5. So yeah, that works out. And here now, we simplify again. Good. So here we simplify now, and when we simplify, notice that the positive 2 root 5 cancels out the negative 2 root 5. So that will leave us with, let's see, at the bottom, let's start with the top. Looking at the top here, and quite frankly, there is nothing we could simplify at the top there. So this would leave us with, this would actually leave us with, you see, if what was inside this root here was the same as this root here, we could have added the 2. But unfortunately, we can't, because that's as far as it goes. We could actually simplify this root and end up with a coefficient of 1, but that doesn't change anything anyway, so it might as well be just so. So at the top, we will end up, let me put it in red because I think that's the answer I'm writing here one time. At the top, we will end up with 4 plus 2 root 5. Yes, and believe it or not, sometimes when you do these kind of questions, you do end up with expressions like these, and that's perfectly normal. Not every time your answer looks sweet and simple as one expression. And all that will be divided by 4 minus 5, which is actually negative 1. So this is our final answer, and I will leave it like that. Of course, some mathematicians, some teachers would advise you not to leave the negative 1 below and just invert the signs of the top. So it's like you just make everything, well, let me just show you. So instead of having negative 1 at the bottom, you just change the sign of everything that is upstairs. Well, that's technically what's happening. So it will be minus 4, minus 2 root 5, minus 2 root 3, minus 15, minus root 15, right? So this could actually be your final answer. In case you don't understand how this happened, it's like, remember, it's like 4 over minus 1, 2 root 5 over minus 1, 2 root 3 over minus 1, root 15 over minus 1. So eventually everything will become negative. So it's your choice, whichever one you choose, you could leave it at that. We have time to do one more. Yes, I think we do. I don't know how much time I took so far. Right, so let's do our last one. Let's do our last one. So here, supposing we have, so this was our last example, number 4. So here we have 2 root 2 plus root 5. Oh, this is an interesting one. So we have 2 roots at the top. And at the bottom, we have 5 plus root 2. Cool. So again, right away, I'm going to go ahead and rationalize. And remember, the whole process of rationalizing, you multiply the bottom and the top by the reciprocal of the bottom. And the reciprocal is simply formed by changing whatever sign you have at the bottom. So here we have a positive sign. So we just multiply by the negative of the like. So we're multiplying this here by 5 minus root 2. And at the top, we do the same. 5 minus root 2. Good. And when you do that, you end up with, again, I'll just simplify. I trust by now we all got the process. So at the top first, we do the 2 root 2 by 5. So that will give us 10 root 2. Then we do 2 root 2 by 2. Oh, wow, that's cool. So this one will leave us with, look at what this, wow, this one is an interesting one. Let me draw an arrow there. I needed to see what is happening here. So this one times this one here. What happened to my arrow there? Okay, my arrow trying to vanish from the top of the screen. Right, so we have 2 root 2 multiplied by negative 2. And this is the same as this. So this is 2 root 2 times root 2, but it's negative, right? So notice now, the 2 on the outside will remain the 2, but the root 2 here times this root 2 here will just give us negative 2. So eventually our answer there will simply be negative 4. 2 times negative 2 is negative 4. So the root times the root will give us just 2. When we multiply root 2 by root 2, we will get 2. But it's negative, so then it's negative 2 times the 2 that is outside here. Oh, this is cool. I trust you could see that. So yes, that's what happened there. That's what happened there. Good. So let's move on. And then you have, so that was on that end. Then we do the same thing with 5. Root 5 times 5. Oh, this one could be a tricky one too. Sometimes you see root 5 multiplied by 5, but notice this 5 is not under the square root. So you cannot say the answer here will just be 5. Yeah, so be very careful here. Here you'll actually get 5 root 5. Yes? If this 5, let me put it in a different color. If this 5 was this, let's say if this 5 was under the square root, then this 5 times this 5 would have just given us 5 and not 5 root 5. But this 5 there is not under the square root, so don't practice that. Be careful. Good. And moving on, 5 times root 2, well, positive 5 times negative root 2, that will actually be negative root 10. Wow, I must admit, this numerator is very interesting. It has some interesting stuff taking place at the top there. All right. And then you divide by 5 times 5 is 25. 5 times negative root 2 is, right now doing these complicated numerators, making the denominator look very simple, man. Making it look very simple. This is supposed to be root 2, not root 5. So 5 times 5 is 25. 5 times negative root 2 is negative 5 root 2. Then positive root 2 by 5, that's positive 5 root 2. and root 2 times negative root 2, that will just be negative 2. Cool? And from here, we just simplify. So this here will cancel this here as customary. That is what will happen. But you have to be vigilant. And then 25 minus, oh no, this cancel. So 25 minus 2, that will leave us with 23. Right now, I have to do the denominator for the denominator working out to be much easier. So we have 23 at the bottom, and at the top, let's see if anything could simplify. No, nothing here could simplify. Well, actually, it could, but here, let's leave it like that. Let me see. No, yeah, you can simplify. So that will leave us with 10 root 2 minus 4 plus 5 root 5 minus root 10. Yep, that's as simple as we could go, believe it or not. We cannot go further than that. Anything beyond that, of course, is expressing each fraction on its own. Like you could put 10 root 2 over 23, 24 over 23. You could do each one by that. But in this case, you don't have to, because really and truly it doesn't affect anything per se. We don't have to go beyond that. So I trust this video was helpful. Again, this was just a continuation of what we started yesterday. I said if I do all this in one video, it would have been too long. Yesterday's video was already 14 minutes when I just did 2 examples because I had to explain the rule first. But yes, this is where we're going to stop for today. And tomorrow's video, I will just come up with different questions so that we could practice. It will be a perfect video in which you could just pause, attempt, and see if we get the same answer. And of course, I'll be applying the various rules. So it's one thing to identify the rules, is another one to ensure that we could apply them. So until the next one, you do take care. And if you have any questions, feel free to leave it in the comment, of course. And until, enjoy the rest of your day.